Okay, students, let us discuss about the structure of disaccharides. In last class only, I have introduced what is meant by disaccharide. So, what is meant by disaccharide, students? Disaccharides is nothing but it is uh, it is a combination of two monosaccharides. It is a combination of two monosaccharides in it, students, and that means disaccharide will be having two monosaccharides units. The two monosaccharides might may be same or it might may be different, students. The two monosaccharides might may be same or different. If you take the sucrose comes under that is disaccharide, students. So sucrose on hydrolysis, what is you are going to get, students? You are going to get glucose as well as fructose, students. You are going to get glucose and fructose, which are okay, students. Similarly, if you are taking that is a disaccharide called maltose. Okay, so sucrose you are having that is it comes under disaccharide. Upon hydrolysis, what you are going to get, students? Upon hydrolysis, you are going to get glucose plus fructose. You are going to get glucose plus fructose, which are two different monosaccharides. Similarly, if you are taking maltose, students, maltose on hydrolysis, you are going to get two same units. Here, we are going to get the two same units, that is glucose and glucose. We are going to get that is two same units. We are going to get two same units, that is glucose and glucose. Understood, students? Here, in the case of sucrose, what you are going to get? You are going to get two different units. Okay, one is glucose, other is fructose. These two are different units, two different monosaccharides. Understood, students? Now let us discuss about the disaccharide sucrose. So in today's class, let us discuss about the structure of disaccharide, students. We'll discuss about the structure of disaccharide. Okay. So here, let us discuss about the disaccharide structure sucrose. First, let us see that is sucrose. Sucrose is having the molecular formula. What is the molecular formula of sucrose, students? That is C12H22O11. Okay, sucrose is having the molecular formula C12H22O11. Students, just the connection has been went off. Just wait. Okay, students. Sucrose is having the formula that is C12H22O11. These on hydrolysis. These on hydrolysis. Okay, these on hydrolysis. What you are going to get here? These on hydrolysis. Okay, students. You are going to get that is glucose and fructose. C6H12O6 plus C6H12O6. You are going to get that is D-glucose and that is D minus fructose. You are going to get D-glucose and you are going to get D minus fructose. D minus fructose. Okay, students. Next, let us discuss now that is the structure of sucrose. So here, if you are taking a disaccharide, so here in this disaccharide, what you are going to get, you take any disaccharide, students. In that disaccharide, two monosaccharide units are present. Already I said in disaccharide, how many monosaccharides are present, students? You are going to have two monosaccharides. In a disaccharide, you are going to have two monosaccharides. That two monosaccharides are bonded to an oxygen. That two monosaccharides are connected with oxygen like this. That two monosaccharides are connected with oxygen like this. Understood, students? You take any disaccharide like sucrose, maltose, or lactose. So here, what is going to take place means these two monosaccharides are connected with an oxygen bond. These two monosaccharides are connected with an oxygen bond, students. So this oxygen bond, what we are calling it as, we are calling it as this oxygen bond. We are calling it as that is glycosidic linkage. What we are calling, students? This we are calling it as glycosidic linkage. We are going to get the glycosidic linkage, students. Okay, what you are going to get, that is a glycosidic linkage. Okay, so if two monosaccharides are attached by the oxygen bond, okay, that linkage we are calling it as glycosidic linkage. So this linkage we are calling it as glycosidic linkage, students. Okay, so now in sucrose also you can see there is a glycosidic linkage, students. In sucrose also you will be having the glycosidic linkage. So let us draw the, that is sucrose structure. Very important, students. This I will show you the glycosidic linkage in the case of that is sucrose. Okay. So sucrose, maltose, and lactose, all these are the, that is very important disaccharides units. So in the examination, definitely you will be getting one question based on this one. Okay. So here I said na, students. Okay. Students are able to see the screen now. I think you are able to see the screen. Okay. So you are going to get the, that is two monosaccharide, students, two monosaccharide units. Okay. You are going to get the two monosaccharide units. Okay, students. Now let us draw the structure of sucrose, students. Okay, in sucrose, so here there is a linkage. This glycosidic linkage is found between the, that is, you know, the sucrose is having, that is, two units. One is glucose, other is fructose. Okay, sucrose is having two unit, students. One is glucose, other is fructose. Okay, so here in sucrose, you can see the glycosidic linkage between C1 of glucose, C1 of glucose and C2 of fructose. So there exists a glycosidic linkage between, that is C1 of alpha glucose, C1 of alpha glucose, okay, and C2 of beta fructose, and C2 of beta fructose. Okay, students. In sucrose, the glycosidic linkage is present between the, I said na, this is the glycosidic linkage. Okay. So this is a two monosaccharides are attached by n, that is a glycosidic linkage. Okay, that glycosidic linkage, that bond is formed between C1 of glucose and C2 of fructose. C1 of glucose and C2 of fructose. Okay, you take any disaccharide, students, like sucrose, maltose, and lactose, you can see the, that is a glycosidic linkage will be present between two carbon atoms. Okay, one carbon will be from one monosaccharide, other carbon will be from the other monosaccharide. Right, students? Now let us draw the, that is the structure of this sucrose. Very important, students, the structure of sucrose. Okay, so before going to draw structure of sucrose, so here one thing I would like to say that this here, here this, it will be formed, okay, from alpha glucose and beta fructose, from alpha glucose and beta fructose. So if you are knowing the alpha glucose and beta fructose, then you can draw the structure of, that is sucrose very easily, students. First I will draw the alpha glucose. Okay, next I will draw the beta fructose, students. Alpha glucose, already you know how the structure will be there. Okay, first I will draw the open chain structure, then you can, after that I will draw the cyclic structure. Okay, so here in the case of alpha glucose, first what we will be having, carbon attached with the hydrogen. Next it is attached with the right side, which group will be there, students? OH will be there. Okay, next. So next, what will be there here? carbon. Next you will be having, that is for the second one, you will be having like this bond, hydrogen, OH. Third one will be left side OH, right side hydrogen. Fourth one, left side hydrogen, right side OH. Okay. Fifth one, hydrogen here, and you can see the bond here, and CH2OH. CH2OH. Now, how can we draw a cyclic structure? So first give the numbering. 1, 2, 3, 4, 5, and 6. Now let us draw the cyclic structure. The cyclic structure, we are calling it as pyranose structure, like this. Okay, students. Carefully observe how I am drawing the structures. Very important, student. So at the vertices, you draw the lines like this. Fine, students. Now you give the numbering. Number 1, number 2, number 3, number 4, number 5, number 6. Okay. First carbon is here, student. Left side, what is there, student? Hydrogen is there. So you have to take hydrogen up and OH down. Second carbon, that is hydrogen up, OH right side down. Third carbon's OH is left side. That means you have to take it as up. And hydrogen is at right side. Right side means you have to write it as down. Coming to the fourth carbon, hydrogen is present at which side, students? Left side. Left side means you have to take it as up. And OH will be, you have to take it as down. Okay. And sixth carbon, you keep it as up position, CH2, OH, and H. We got, what we got, students? We got alpha D glucose. We got alpha D glucose. Fine. Now, next which structure we have to draw, the students? We have to draw beta D minus fructose. Why we have to draw beta D minus fructose, students? Because sucrose is found between alpha glucose and beta fructose. Now let us draw the beta fructose, students. Students, if you are able to draw this structure, then you can draw this structure very easily, students. Okay, first you have to remember this structure. If you are able to remember this structure, you can remember this structure very easily. Okay, you can derive the structure from this structure. Next, let us draw that is beta D fructose. We will draw that one. So here, beta D fructose. How can we draw that is beta D fructose? In order to draw the beta D fructose, first let us, okay, first let us go to that is beta D fructose. First we will draw that is normal structure. After drawing the normal structure, then we will draw the cyclic structure of the beta D fructose. Okay, students. So it will be very easy, students. If you know alpha D glucose structure as well as beta D glucose structure, it will be very easy for you. Okay. Now let us draw that is beta D fructose. So here in beta D fructose, so where will be the OH, students? OH will be at that is left side. OH will be at the left side, and CH2OH will be at that is right side, students. Okay. So you can draw the beta D fructose, students. So you can see in the last class also. Otherwise, if you go to this last class, BS class, you can see the beta D fructose. So here you have beta D fructose. Okay, I hope everybody is seeing this structure. Students, are you able to see the beta D fructopyranose structure, students? Where is the OH group and where is the CH2OH group? CH2OH group is at the right side, OH group is at the left side. Are you able to see the screen, students? Please message in the chat box, students. Are you able to see the beta D fructopyranose structure? Students, are you able to see the beta D fructopyranose structure on your screen? Okay, fine, students. So once again, I will draw the structure, student. No problem. Okay. So because why I am drawing the beta D fructopyranose? Because sucrose is formed by alpha D glucose and beta D fructose. So Let us draw the beta D fructose. So that you will be knowing. Okay, students. Yes, here I will draw the beta D fructose. Okay, students, just a minute. Connection has went off, student. Just a minute. Now again, we got connection. I'm sharing the screen. Wait. Okay, students. Now I hope everybody is seeing the screen. Okay. Let us draw that is beta D, that is fructose. So here for beta D fructose, what you have to take, students? We have to take that is OH will be at the left side. Carbon CH2OH will be here. Okay. And this is the first carbon, students. This is the first carbon. This is the second one. Next carbon. Okay. Third carbon OH group is at which side, student? That is left side only. Okay. Hydrogen will be at. Next is third. Fourth is HOH. Next, that is fifth is this one, students. And you can see that is a glycosidic linkage here. Okay, students. Last one is CH2OH. That is our sixth carbon, students. Okay. Now you can see 1, 2, 3, 4, 5, 6. So this is our beta D fructose, students. Now I will draw that is Haber structures of this one. Let us draw the Haber structure. So we have to draw that is a 5-membered ring. We have to draw the 5-membered ring, that is Furanose ring. So this is our 5-membered ring, students. Okay. Okay, students. Furanose ring we have drawn. Now draw the straight lines which is passing through the vertices, which will pass the 4 vertices. Okay, students. Students, okay. Sorry for interruption because connection is going. Okay, students. Please be patient. Okay. Connection is going. Okay. Now I hope everybody is seeing the screen now. Okay, students. Let us draw the structure. Okay. Now I will write the. Now I will assign the carbon atoms. I will assign the first carbon. Where is first carbon, students? Here CH2OH. CH2OH is at which side, student? It is at right side. CH2OH is at which side, student? Right side. Right side means we have to write it down. OH is at which place, students? Left side. Left side means up. This is the first carbon, student. This will be the second, third, fourth, fifth, and sixth, student. Third carbon, where is OH, student? OH is at left side. Left side means you have to keep it as up. Top you have to keep. And hydrogen is at right side, bottom. Next, hydrogen, you see, students, where hydrogen is the left side. Left side means up. OH, where it is right side. Right side means down. Next, CH2OH, which is, you have to give the priority, you keep it as upside position, students, CH2OH. And hydrogen, where it is, students, it is at, that is, you can keep it as, here you can keep. Okay. So this is our, what is the name of this structure, students? Beta D minus fructose. Now the sucrose is the combination of alpha D glucose and beta D fructose. Okay, students. Now let us draw the structure of sucrose. So what I said to students, sucrose structure. If you want to draw the structure of sucrose means you have to take the 2 units. You have to take the 2 units, students. Okay, that is glucose unit you have to take, and you have to take the fructose unit. And what I said, students, there will be the glycosidic linkage where the oxygen atoms will be attached. The oxygen atoms will be attached at C1 carbon of alpha glucose and C2 carbon of beta fructose. You can see the oxygen linkage, this glycosidic linkage will be present between C1 of alpha glucose and C2 of beta fructose. Now let us draw the structure that. Okay, students, now I am going to draw the structure of sucrose by taking alpha D glucose. Okay, by taking alpha D glucose and beta D fructose. Okay, students. The structure which I am going to draw is somewhat easier one compared to the textbook structure. Okay, students. So let us draw the structure. So now I am going to draw the structure of, this is what we call sucrose. So sucrose is a combination of glucose and fructose. Okay, students? Just a minute. Fine. So first you draw the structure like this. First you draw the glucose structure like this. Pyranose structure like this you have to draw. Right. Below that you draw that is fructose structure, student. Below that you draw fructose structure like this. Okay, students. Now you know you give the numbering. This is C1 carbon, C2, C3, C4, C5. And C5 will be upside, C6 will be upside, students. Okay, I will draw this one. See it carefully how I am drawing, just you see. Here what will be there, students? Hydrogen, OH. Here what will be there, students? Same, hydrogen, OH. Here what will be there, students? Here OH will be upside, hydrogen will be down. And here, that is hydrogen will be up, OH will be down. And here sixth one is CH2OH and H. This is sixth carbon, student. Fine. Now you give the numbering for the fructose. How will you give the numbering for fructose? First you draw that is lines which will pass through the vertices. 1, 2, 3, 4. Right, students? And CH2OH will be down and OH will be up. And here next one will be, that is first carbon, second carbon, OH will be upside here. OH will be upside, right? And hydrogen will be down. Fourth carbon, hydrogen, OH. Okay, fifth carbon will be here and sixth one will be upside, CH2OH and that is H. CH2OH and H2. Okay, now here, now you give the numbering, students. First carbon, second, third, fourth, okay, fifth and sixth. Right, students? Okay. Now here what will happen, student? The OH, where will be the glycosidic linkage will be formed at this position? The glycosidic linkage will be formed at C1 carbon and C2 carbon. So you can see the glycosidic linkage will be formed between C1 the carbon of alpha glucose, C1 carbon of alpha glucose and C2 carbon of beta fructose. So now you can see this C1 carbon and C2 carbon will be connected by an oxygen bond. This we are calling as glycosidic linkage. How it will be connected by oxygen bond means, you see, students, here hydrogen from here and OH from here will be eliminated. Water molecule will be eliminated. Okay. Hydrogen from the C1 of glucose and OH from the beta fructose. So it will eliminate. H from upside, OH from downside will be eliminated. And what is left over, students? The leftover one is oxygen. This oxygen will be in contact with C1 carbon of alpha glucose and C2 carbon of beta fructose. Okay, students. Up to this, you understood or not? Please message in chat box, students, so that I will come to know whether you understood or not. Because I will draw the structure. Please message in chat box, students. Up to this, whether you understood or not, please message in chat box. Still, students, please message in chat box so that I will come to know how many students you understood and how many you didn't understood. You can message in chat box. One student is asking, is alpha sucrose and beta sucrose existed? No, it won't exist. Okay, we have only one type of sucrose. If you have any doubts, you can message in chat box, students. Understood or not? Only thing is, students, first of all, you should know how to write that is alpha D glucose structure and beta D fructose. If you know the alpha D glucose and beta D fructose, that you can convert into Haber structures. When you know the Haber structures, then you can join easily. Okay, fine, students. Now I will draw the structure so that you will be knowing. Wait, students, I will draw a structure now. Still some students are messaging in the chat box. Okay, student. Now I will draw a structure. Now I will draw a structure, students. Wait. So first, we draw a structure like this, student. Okay. How to draw sucrose structure, I am showing to you. Right. Next, draw a structure like this. Okay. Okay, students. We draw a structure like this here. This is C1 carbon, students. Carefully you see, this is our C1 carbon. And you can see there is an oxygen will be present. Okay, oxygen will be attached like this to the C2 carbon of fructose. Students, see carefully. Okay, students. Fine, students. CH2OH. Right. So now you can see this is which carbon, student? This is C2 carbon. This is C2 carbon of which one, students? C2 carbon of, that is fructose. C2 carbon of beta fructose. C2 carbon of beta fructose. This is C1 carbon of alpha glucose. Okay, alpha glucose. Or you can write it as, if you want to write clearly, alpha D glucose. Or you can write here it as, that is beta D minus fructose. Now you draw the remaining atoms. So how the glycosidic linkage is formed, students? It is formed by the elimination of water molecule. Hydrogen from above one and OH from the below one, and you will get the glycosidic linkage. And give the numbering first. First carbon, second carbon, third carbon, fourth. Next it is fifth. The above one will be sixth. Okay, now you draw a structure here. Here what you will be having? Hydrogen. Okay. and OH. Next here you will be having OH at upside, hydrogen will be down, and here hydrogen will be up, OH will be down. Next you'll be having CH2OH upside, hydrogen will be down. Right, students? And here also the same case we'll be having. That is what will be, and first you give the numbering, students. This is first carbon, second carbon, third carbon, fourth carbon, okay, fifth carbon and sixth carbon. Fine, students. Third carbon same. OH will be upside. Hydrogen will be down. Fourth carbon H will be up. OH will be down. Next CH2OH, and you will be having the H. Right, students? Have you understood or not, students? Please message in the chat box, students, so that I will come to know how many people you understood or not. I will write oxygen with other color. Just a minute. Okay, this we are calling it as glycosidic linkage. This linkage we are calling it as glycosidic linkage, which is found between C1 and C2 carbons of alpha D and beta. Students, once you see the structure, please see the structure, students. I hope you understood. Please message in chat box, students, so that I will come to know. Please message in chat box, students. So that I will be knowing whether you understood or not. Is it clear, students? Now are you able to draw structure of sucrose? Yes, fine, students. Okay. Now let us discuss about the one student is asking about, sir, all disaccharides have this glycosidic linkages. Yes, we have all, we have, that is for sucrose we will be having, for lactose we will be having, for maltose also. All three will be having glycosidic, because disaccharide itself, the name tells us it is a combination of two saccharides, two monosaccharides. So it should, the two monosaccharides, it should be connected with some bond. Okay, then only we will get the disaccharides. If two monosaccharides are connected side by side with a bond, then only we are going to get the bond. That is disaccharide, that is glycosidic. Okay, because what do you mean by disaccharide, students? Disaccharide is nothing but it is a combination of two units of monosaccharide. Disaccharide is a combination of two units of monosaccharides. Combination we are saying. Combination of monosaccharides. Combination means combining. So that two monosaccharides are combined by an that is glycosidic bond. Okay, the two monosaccharides are joined by a bond. That bond we are calling it as glycosidic. I hope you understood. Okay. Next, let us discuss the, that is structure of that is now let us discuss about the properties. We will discuss about the properties. So what are the properties of this sucrose? There is an interesting property of sucrose is there, students. I will say that property. Okay, what is that property we used to call sucrose on hydrolysis? As I said that sucrose on hydrolysis, it will give D plus glucose and fructose. Okay. One more student is asking, sir, only disaccharides are only having glycosidic bond or polysaccharides? Polysaccharides also will be having the bond. Okay. Okay, just okay. Let us go for that is this property is there. Sucrose, we are calling it as invert sugar. Sucrose, we are calling it as invert sugar. Very, very important, students. Sucrose, we are calling it as invert sugar. So why we are calling it as invert sugar? So before going to discuss about this invert sugar, why we are calling this invert sugar, let us have a look. This sucrose is a dextrorotatory compound. Sucrose is a dextrorotatory compound. That means, what do you mean by this, student? What do you mean by this sentence? Sucrose is a dextrorotatory compound means it will rotate the plane polarized right to the right side direction. It will rotate the plane polarized right to the right side direction. Okay, students. So sucrose will rotate the plane polarized right to the right side direction. Now what we are doing, students, means we are we are doing the hydrolysis. We are doing the hydrolysis of sucrose. So when we are doing the hydrolysis of sucrose, what we are going to get, students? When we are doing the hydrolysis, we are going to get that is glucose and fructose. We are going to get the glucose and fructose. Already you know, sucrose on hydrolysis, you are going to get that is glucose and fructose. Or you can write completely like you can get alpha D, that is alpha D glucose and that is beta D fructose. Just a minute, I'll write the complete one. Okay, alpha D glucose and beta D fructose. Sucrose on hydrolysis, you are going to get alpha D plus glucose plus beta D minus fructose. Beta D minus fructose. Okay. Sucrose is an dextrorotatory compound, student. Okay, it is a dextrorotatory compound. So this on hydrolysis, you are going to get two compounds called alpha D glucose and beta D fructose. So here, alpha D glucose and beta D fructose you are going to get. Now, here one thing what I am saying to is the parent compound. The parent compound is a dextro compound. This is a which compound, student? Dextro compound, dextrorotatory compound. Sucrose is a dextrorotatory compound, student. Okay. So, but the products of sucrose. Okay. So, we are taking a sucrose solution. Sucrose is a dextrorotatory compound, student. But the solution of sucrose is a levorotatory compound. But the solution of sucrose is a levorotatory compound. Why the solution of sucrose? Why the products of sucrose is a levorotatory? What is the reason here? I will explain. So you know that the previous class I said that about the plane polarized light. So plane polarized light, an optical active compound will rotate the plane polarized light to the certain extent, okay, certain angle. If you are taking the angle, the dextro rotation of glucose is given as plus 52.5 degree, plus 52.5 degree, okay. And if you are taking the lever rotation of fructose, you know this minus symbol means it is a lever rotatory compound. So it will rotate the plane polarized to the extent of minus 92.4 degree. Minus 92.4 degree. Understood, students? So sucrose is a dextrorotatory compound, but the aqueous solution of sucrose. That means after doing the hydrolysis of sucrose, the products which you are going to get, that product, if you are testing the optical activity, that products will show the optical activity of levorotatory. Why it will show the levorotatory, students, means because glucose will rotate the plane polarized clockwise direction to an angle of how much? Plus 52.5 degree. Rotate the plane polarized to an angle of plus 52.5 degree. Understood? But fructose to how much extent? Okay, students, let us discuss this one. Okay, so we are discussing about that is, I hope everybody you are seeing the screen, student. Students, are you able to see the screen or not? Students, are you able to see screen on your mobile, students? Hello, students, are you able to see the screen? Okay, fine, students. Okay, okay, students. So here, let us discuss about the that is. So now you see the students that is how much angle it will rotate plus 52.5 degrees. And if you are taking the fructose it is having that is how much that is minus 92.4 degrees. So you see the rotation. Fructose is rotating to how much extent, student? Fructose is rotating to that is more minus 92.4, whereas glucose is rotating to only plus 52.5. And finally, if you compare these two, that is angles, you are comparing these two angles, which angle is more, student? That is 52.5 degrees more or 92.4 degrees? 92.4 degrees. That means overall the solution will be having the which behavior, student? It will be having the levorotatory behavior. Okay, it is having the levorotatory behavior. I hope you understood, students. Okay, sucrose on hydrolysis, you are going to get glucose and fructose, student. Fructose glucose is having the specific rotation of that is 52.5 degree, and fructose is having the specific rotation of 92.4 degree. Overall, the fructose is having the more levorotatory. Okay, just a minute, student. Okay, the lever rotation of fructose is more, students. We are going to get that is the lever rotation of the fructose is more, students. Okay, so when the lever rotation of fructose is more means that is finally this mixture will behave as which type of mixture, students? Finally, this mixture it is behaving as an lever rotation. It's behaving as a lever rotator. It's behaving as a lever rotator. So the parent compound is dextro. Okay, the reactant is dextro, but the products are having which type of rotation? Levo. That means from dextro rotation to levo, the rotation has been changed. Okay, from dextro to levo, it has been changed. Okay, students. From dextro to levo, what it has been changed, students? From dextro to levo, okay, that is sign has been changed. Okay, so that's why this we are calling it as invert sugar. This we are calling it as invert sugar. Why sucrose is calling it as invert sugar means because okay, students, just a minute. I hope you are seeing the screen, students. Okay, so we will end the class within few minutes. So this we are calling it as invert sugar. So why we are calling it as invert sugar means sucrose is having an dextrorotatory compound, whereas the products of sucrose is having the levorotatory compound. Okay, sucrose is having dextrorotation, and the products of the sucrose is having the levorotation. So the configuration has been changed from that is dextro to levo. The direction has been changed from clockwise to anti-clockwise. The sign has been changed from plus to minus. So that's why we are calling it as invert sugar. That's why we are calling it as invert sugar. That means the rotation has been inversed. So when clockwise rotation is inverse, what we are going to get? We are going to get the anti-clockwise. That's why we are calling it as invert sugar. Okay, students. So sucrose on hydrolysis, we are going to get glucose and fructose. Glucose is having Okay, students. So the configuration that we are calling it as uh, invert sugar, right, students? Understood? That's why we are calling it as invert sugar, because sucrose is a dextrorotatory compound. It will rotate the plane for the right side direction, whereas the compounds of the sucrose, the hydrolysis products of the sucrose is having the levo rotation. Okay, the rotation has been changed from, that is, dextro to levo, and the sign has been changed from plus to minus, and the clockwise rotation has been changed to anti-clockwise. That's why we are calling it as sucrose. We are calling it as invert sugar. Understood, students? Please message in chat box so that we will. Students, please message in chat box up to this. Have you understood or not? If you want explanation, once again I will do. Please message in chat box, students, so that I will come to know. Students, message in chat box, students. Have you understood or not what is meant by invert sugar? Students, message in chat box so that I will come to know, because 2 to 3 times the connection has been interrupted. What is invert sugar? Have you understood or not?